Hello students, let's do Pythagoras Theorem, exercise 18. This is on page number 208. Now, Pythagoras Theorem says that in a right-angled triangle, so we have two right-angled triangles here for this particular question. In a right-angled triangle, that is, there is one angle that's 90 degrees and the side that is opposite that, which is known as the hypotenuse. The square of the hypotenuse is equal to the sum of the squares of the other two sides. So this is what the Pythagoras theorem says, and we're going to apply it in this question. We are with question 6. In the given figure, so we're talking about this figure here, angle ACP. So we have ACP is equal to angle BDP, that is angle B, D and P, and they are equal to 90 degrees. So here we have the two angles showing that they are 90 degrees each. So let's write that there. So this is 90 degrees. So here also we have 90 degrees here. So this is 90 degrees. Then what else does the question say? It says BD is 9 meters. Now where is BD? BD is here and that is 9 meters. PA, where is PA? PA is equal to PB is equal to PB. That's why you have these strokes here to show that both these sides are equal. So this is given and this is the hypotenuse, as you can see, because it is opposite the right angle. So the hypotenuse here is 15 meters. Here also the hypotenuse is the one that is opposite 90 degrees and that is also 15 meters. Now what are we asked to find? We are asked to find first CP. Now where is CP? CP is here. So we are asked to find CP. So that means we're only going to look at this red angle now. This red triangle in which one measurement is given, one more measurement is given. We have to find the measurement of the third side. So here let's begin by saying angle ACP is equal to angle BDP, which is 90 degrees given to us in the question. AC is 12 meters, BD is 9 meters. Then we have PA is equal to PB is equal to 15 meters. Now we have to find CP. Based on all these details given, we have to find CP. So now in this triangle, right angle triangle ACP, AP square, that is the hypotenuse square, is equal to AC square plus CP square. How do we get that? That is based on the Pythagoras theorem. Now we are going to substitute all these with values wherever it is applicable. Now AP square. Now what is AP? AP is here AP and the measurement is 15. That means 15 meter square. So let's write that. So this is equal to 15 meters and the whole thing square is equal to AC square. AC is 12 meters, 12 meter square plus CP square, which is what we are going to find out. We need to find out CP and we don't know the value, so we're going to leave it as it is. 15 meters square means 15 meters into 15 meters. So this is equal to 12 meters into 12 meters. So plus CP square. So this is equal to 15 into 15 is 225 meter square and this is equal to 12 into 12 is 144 meter square plus CP square. So we are going to leave CP here on this left hand side. So CP square is equal to, now this 225 meter square, I'm going to write it the side. So that is 225 meter square. Now what are we going to do with this 144? We're going to take it to the other side. So it becomes minus 144 meter square. Now let's subtract 225 and 144. So when you minus the two, what do you get? CP square now is equal to 81. Now we need to find CP alone, isn't it? So to find CP, we say CP is equal to the square root of 81. That means there is a number, when you multiply it twice, you get 81. Which number is that? 9, isn't it? 9 into 9 is 81. So that means we have found the value of CP, which is the square root of 81, and that is 9. So the answer is 9 meters. So we have found CP to be equal to 9 meters. Now question 2 is find PD. Now where is PD? P is here and D is here. So this measurement is what we need to find. We have to find the measurement of this side. So this time we're going to look at the triangle in green. Okay, that is PDB or BDP. We're going to look at this triangle that is in green. So in the right angle triangle BPD, we can use the Pythagoras theorem. So according to that, PB square, that is the hypotenuse, is equal to the sum of the squares of the other two sides. So that is what we have written here. Now let's substitute the values. Now PB is given as 15 meters. So that will be equal to 15 meters square. Isn't it? 15 meters square is equal to BD, which is 9 meters. So that is 9 meters square plus PD square, and that is what we don't know, and we're going to find out PD. So this is equal to 15 meters square is 15 meters into 15 meters, and that is equal to 9 meter into 9 meters. Square means twice, plus PD square, which we don't know and we're going to find out. 15 into 15 is 225 meters square. This is equal to 9 nines are 81. 81 meters square plus PD square. Since we're going to find out PD, we're going to leave PD here, PD square, and we're going to move 81 meters square to the other side. Now what do we already have on the other side of the equal to sign? 225 meters square. So we already have that. So 225 meters square. We're going to transpose 81 meters square there. So 225 minus 81. So that is equal to PD square is equal to, when you minus these two, what you get is PD square. So that will be 144. So now we have to find only PD, isn't it? So PD will be equal to the square root of 144. That means there is one number. When you multiply it twice, you get 144. Now that is 12, but we can also find out the square root by the prime factor method. So let's do that to help you understand better. So let's do that. So let's take 144 divided by prime numbers. So I'll take 2. 2 sevens are 14. 2 2s are 4. That's 72. 2 into 36 will give us 72. Then 2 into 18 is 36. 2 nines are 18. 3 threes are 9. So again, this is 3 ones are 3. So the prime factors of 144. So I'm finding the square root of 144. Let me write it here. Let's write all the prime factors. So we have 1, 2, 3 and 4 2's, and we have 2 3's, 1 and 2. Now we're going to pair it up. That means I'm going to put it in groups of 2. So there are 2 numbers here, there are 2 numbers here, there are 2 numbers here. Because it's a square root, square means 2, I'm putting them in groups of 2, or I'm pairing them. Now I'm going to continue to find the square root. Now this is, remember, square root, so we put the square root sign. Now in the next step, we don't put the square root sign, but from each pair we're going to take 1. So from the first pair I'm taking 1, 2. From the second pair I'm taking 1, 2. From the third pair I'm taking 1, 3. Now let's multiply. 2 2's are 4. 4 3's are 12. That means the square root of 144 is 12. So that means we have found the answer. PD is equal to 12. And here we know it is in meters, so we will write PD is equal to 12 meters. So we have found our answer to the second question. And what is the answer? PD is equal to 12 meters. Now we have to find the value of CD. Now where is CD? Now CD is this whole thing, isn't it? This whole thing is CD. That means I have to find CP, and if I add it to PD, I will get my answer. I will know the length of CD. So let's begin. CP is given as, which we found out to be 9 meters. PD we found out to be 12 meters. So let's write it down here. So CP is given as 9 meters. Then PD is 12 meters. So now we will be able to find the length of CD. Okay, now how do we do that? By adding CP and PD. So let's add it up. CP is 9 meters and PD is 12 meters. Let's add this up. 9 plus 12 is 21. So 21 meters. So we have found the length of CD. CD is 21 meters. So this is our answer. The length of CD is 21 meters. Question 7. In triangle PQR, so we have triangle PQR, this triangle in green, angle Q is 90 degrees. So angle Q is 90 degrees. Find PR. First question is find PR, that is PR is the hypotenuse here because it is opposite the 90-degree angle. So we have to find the hypotenuse here if PQ is 8 centimeters. So PQ is given as 8 centimeters and QR is given as 6 centimeters. So first let's start with the first question. We are going to find the hypotenuse. So what is given? PR is what we are finding. What's given to us is all this. PQ's measurement, QR's measurement, and we are told that PQR is 90 degrees. So now we are going to use the Pythagoras theorem to find the value of the hypotenuse. What does the Pythagoras theorem say? The square of the hypotenuse is equal to the sum of the squares of the other two sides. So let's substitute the values that we have. So PR square we don't know because that is what we're going to find out. So we'll write it as it is. So PR square is equal to how much is PQ? PQ is given as 8 centimeters, so that will be 8 centimeters square plus QR. How much is QR? QR is 6 centimeters, so that is 6 centimeters square. So now let's find the value of PR again. PR square is equal to 8 into 8. Okay, 8 centimeters into 8 centimeters plus 6 into 6 because it's a square. So PR square is equal to 8 8s are 64 plus 6 6s are 36. So PR square is equal to 64 plus 36, which is 100. Now to find the value of PR, we have to find the square root of 100, which is a number which you multiply twice, you get 100. That is 10. 10 into 10 is 100. Now let us anyway find the square root of 100 by the prime factor method. Let's begin with 5. 5 2s are 10, 0. Then again with 5, 5 4s are 20. Then continue with 2. 2 2s are 4. Again continue, 2 1s are 2. So the prime factors of 100, okay, we've found out now. So that is 5 into 5 into 2 into 2. Now we're going to pair up. So I'm going to take the two 5s and put it together, the two 2s and put it together. Now we're going to find the square root of 100. This time we're going to remove the square root sign and take only one from each pair. So 5, 1 5 and 1 2. So the square root of 100 is 10. Okay, so we have found the value of PR. PR is equal to 10 and the unit is centimeters. So we will write 10 centimeters. So this is our answer. So we have finished the first question. We were asked to find PR and we found PR to be 10 centimeters. Then let's go on to the second question. Here we are asked to find PQ. Okay, so here PR is given as 34 centimeters. So PR, the hypotenuse, is already given to us and QR is given as 30 centimeters. So now let's apply the Pythagoras theorem with all these details. So according to that, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So let's substitute the values here. PR is already given to us. So that was 34 centimeters. So here 34 centimeters square is equal to PQ. PQ is what we are going to find out. So we're going to leave it as PQ square. Now QR is given as 30 centimeters. So that is 30 centimeters square. So this will be 34 into 34. This is equal to PQ square plus 30 into 30. Now 34 into 34 is 1156. 1156. This is equal to PQ square plus 30 into 30. 3 threes are 9. Add the 2 zeros, 900. Now we are going to keep only PQ square here. So on the other side, we already have 1156, which I'm going to write here. So that will be 1156. Now I'm going to transpose this plus 900. It is on this side. I'm going to take it to the other side. So it becomes minus 900. So now PQ square is equal to 1156 minus 900, which is equal to 256. Now we need to find PQ, and PQ is equal to the square root of 256. So let's find all the prime factors of 256. Let's begin with 2. 2 ones are 2, 2 twos are 4. There's 1 left, 16, 2 eights are 16. Now continue with 2. 2 sixes are 12, 2 fours are 8. Continue. 2 threes are 6, 2 twos are 4. Again with 2. 2 into 16 is 32. So we'll continue again. 2 into 8 is 16. Again with 2. 2 fours are 8. Again with 2. 2 twos are 4. The final step is 2 ones are 2. Now we are going to find the square root of 256 by writing all the prime factors that we just found. Let's count how many 2's there are. 1, 2, 3, 4, 5, 6, 7, 8 2's. So let's write that 1, 2, 3, 4, 5, 6, 7 and 8. Now we're going to pair them up. So there's one pair here, one more and one more pair. Now to find the square root of 256, we're going to remove the square root sign and take only one from each pair. So from this pair, I'm going to take 1, 2, then from this pair another 2, then from the third pair one more 2, and from the last pair I'm going to take one more 2. So now the square root of 256 will be, when we multiply, 2 2's are 4, 4 2's are 8, 8 2's are 16. So 256, the square root is 16. So we have found the measurement of PQ, and PQ is 16, and that is 16 centimeters. So we have found our answer. PQ is equal to 16 centimeters. Question 8. Show that the triangle ABC is a right angled triangle. Okay, so we have to prove that the angles measurements that have given to us make a right angled triangle. And what are the measurements? AB is 9 centimeters, BC is 40 centimeters, and AC is 41 centimeters. We have been given the measurements of three sides, and we have to show that this is forming a right angled triangle. Now, AB is 9 centimeters, BC is 40 centimeters, AC is 41 centimeters. Now, let us apply the Pythagoras theorem. This triangle will be right angled if the square of the largest side, remember the largest side is the hypotenuse. So, if the square of the largest side is equal to the sum of the squares of the other two sides. So, if that is equal by applying the Pythagoras theorem, then we can say that these three sides form a right angled triangle. So let's begin. AC square is equal to AB square plus BC square. Now why did we take AC square? Because that is the largest side. Can you see? So that is the hypotenuse. So let's take that 41 centimeters. So this will be equal to 41 centimeter square is equal to AB square, that is 9 centimeter square. AB is 9 centimeters plus BC. How much is BC? 40 centimeters, the square of this. So now let's work this out and see if both the sides are equal. So this is 41 into 41, and here it is 9 into 9 plus 40 into 40. 40 into 40. So here how much is 41 into 41? That is 1681. 1681. Now on the right hand side, what do we have? 9 nines are 81 plus 40 into 40. 4 fours are 16 and add the two zeros. So on the left hand side, we have 1681. On the right side, 81 plus 1600 will be 1681. So we have proved that this is a right angle triangle by applying the Pythagoras theorem. So the left hand side is equal to the right hand side. Question 9. In the given figure, angle ACB is 90 degrees. Where is ACB? A, C and B is 90 degrees. So let's write that down. So this is 90 degrees. And that is equal to angle ACD, which is on the other side. So this is also 90 degrees. Now, if AB is 10 centimeters, so AB is 10 centimeters, BC is 6 centimeters, and AD is 17 centimeters, we have to find the length of AC, which is here, AC, and we have to find the length of CD. So first we have to find the length of AC. So let's begin by writing angle ACB is 90 degrees, which is equal to angle ACD, and all these measurements. So this is already given to us. Now we are going to make use of the Pythagoras theorem to find AC. So in this right angle triangle ABC, BC, we are taking only the triangle ABC, that is ABC, because we're going to find out AC. So this is what we are going to find out. We're going to find the measurement of AC. So in this triangle, we only want the measurements of BC and AB. So we don't want this for this particular question. So here we're going to apply the Pythagoras theorem, according to which so let's substitute the values. AB is 10 centimeters, so that will be 10 centimeter square, AB square, isn't it? Is equal to AC is what we're going to find out. So we're going to leave it as AC square plus BC square. BC is 6 centimeters, 6 centimeters square. So this will be equal to 10 into 10, which is equal to AC square plus 6 into 6. So 10 into 10 is 100. This is AC square. 6 into 6 is 36. Now we are going to find the value of only AC square first. So we're going to write 100, which is on the other side, and we're going to move this plus 36 to the other side. So it's going to become minus 36, minus 36. So now AC square is equal to 100 minus 36, which is equal to 64. So now we're going to find AC alone. So to find AC alone, we have to find the square root of 64. Now, which is a number which you multiply twice, that will give you 64. 8, isn't it? So the square root of 64 is 8. That means AC is equal to 8 centimeters. So we have found the answer. AC is equal to 8 centimeters. Now, if you want to find the square root by the prime factor method, let's do it. So this is divided by 2. 2 3s are 6, 2 2s are 4. Again, you divide 2. Now 2 into 16 is 32. 2 8s are 16. 2 4s are 8. 2 2s are 4. And 2 1s are 2. Now, let's write down all the prime factors of 64. Putting the square root sign first, let's count all the 2's. 1, 2, 3, 4, 5, 6. So that is 1, 2, 3, 4, 5 and 6. Now the next thing we do is we pair them up. 1, 2, 3. We've got 3 pairs. So the square root of 64 will be, this time remove the square root sign and write only 1 from each pair. 1, 2, 3. 2 2s are 4, 4 2s are 8. So the square root of 64 is 8. Okay, so this is the answer. We have found the answer. AC is equal to 8 centimeters. Now we have to find the value of CD. So here in this right angle triangle ACD. So this time we're going to take this other side ACD because we have been asked to find CD and we don't know CD. And CD belongs to this triangle which is on this side. So in this right angle triangle, AD is given as 17 centimeters. AC is given to us as 8 centimeters. We're going to use the Pythagoras theorem and find out. Now AD square, that is the square of the hypotenuse, is equal to the sum of the squares of the other two sides. So let's substitute with the values given to us. AD is already given to us, so that is 17 centimeters. So that is 17 centimeters square is equal to AC square. Now AC is also given to us, that is 8 centimeters. So 8 centimeters square plus CD square. Now that is what we are going to find out. So now 17 centimeters means 17 into 17 when you square it up. This is equal to 8 into 8, the square of 8 plus CD square. Now 17 into 17 is equal to 289. This is equal to 8 into 8, that is 64, plus CD square. Now we are going to find the value of CD square. So on the other side of the equal to sign, we have 289. Now we are going to transpose the 64 to the other side. So it's going to become minus 64, minus 64. So CD square is equal to 289 minus 64, which is 225. So to find CD, we have to find the square root of 225. So let's find the prime factors of 225. Let's begin with 5. 5 fours are 20, then you carry 2, you have 25, 5 fives are 25, again continue with 5, 5 nines are 45, this time we continue with 3, 3 threes are 9, and again with 3, 3 ones are 3. So now the square root of 225 will be equal to, put the square root sign, put all the factors, so 5 into 5 into 3 into 3. Now pair up the prime factors. So here one pair I have, another pair. So continue, square root of 225 is equal to, remove the square root sign, write one number from each pair, that is 5 into 3. 5 threes are 15. So the square root of 225 is 15. That means we have found the value of CD. CD is equal to 15 centimeters. So we have an answer here. CD is equal to 15 centimeters. Question 10. In the given figure, angle ADB is 90 degrees. Where is that? ADB is 90 degrees. AC is equal to AB. That is AC is equal to AB, and we can see with the help of this one stroke here, we can make out that these two sides are equal. And this is equal to 26 centimeters. That means this side is also equal to 26 centimeters. And they also told us BD is equal to DC. Where is that? BD is equal to DC. So we have two strokes to show that these two line segments are the same measurements. Now if the length of AD, where is AD? AD is this line. If that length is 24 centimeters, we are asked to find the length of BC. Now BC is this whole thing. To find the length of this whole thing, we have to add up BD and DC. So we have to find out either BD or DC, any one, because both are equal. If we find one, that means the other measurement is also the same. So if we add up BD and DC, we can get the length of BD. So let's begin. Angle ADB is 90 degrees given to us. AC is equal to AB equals 26 centimeters. And AD is equal to 24 centimeters. All this is given to us. Now BD is we are told is equal to DC. So now it's going to be easy to find BC. So we're going to use the Pythagoras theorem and take one of these right angles. So AC, well, let's take this. The square of the hypotenuse is equal to the sum of the squares of the other two sides. So let's substitute the values of whatever we have. So AC we have, so let's write it as 26 centimeters square is equal to AD also we have, that is 24 centimeters. So that is the square of 24 centimeters square plus DC square. Now this is what we have to find out. We don't know. So we're going to write this as DC square itself. So here this is going to be 26 into 26. This is equal to 24 into 24 plus DC square. DC square. So now how much is 26 into 26? That is 676, and that is equal to 24 into 24, which is equal to 576 plus DC square, because we're going to find out DC. So now we're going to find out DC square first. So DC square will be on the side, and on the other side we already have 676. We are transposing 576, so it becomes minus 576. So now DC square is equal to 676 minus 576, which is 100. Now to find the value of DC, we want only DC now, isn't it? The square root of 100. Now, what is the number which you multiply twice, you get 100? That is 10, isn't it? So square root of 100 is 10. That means we have found the value of DC. DC is 10 centimeters. So this is the first part of the answer. Now we have been asked to find the length of BC, that is from B to C, and we have only found DC now. So let's remove this question mark sign and put 10 centimeters there. So here we have 10 centimeters. Now remember, these strokes tell us that these two sides are the same. If this is 10, then this also is 10. So this is 10 centimeters. So now we're going to find the value of BC. So BC will be equal to BD plus DC. So BC is equal to, now BD is 10 centimeters and DC is 10 centimeters. So that will be 10 centimeters plus 10 centimeters. So BC is equal to 10 plus 10, that is 20 centimeters. So we have found the value of BC, and BC is equal to 20 centimeters. So we will stop with this for now, children. In our next video, we will continue with the remaining questions. Thank you, children.